Okay, so this is my second example about applications of Maxima and Minima. Doon sa aking first example, pansin ko nyo doon, gumamit pa ako ng first derivative test to prove to you that the greatest carrying capacity or the maximum area is, the area is maximum if the depth of the gutter x equals to 7.5 centimeter. Ano? Pero sa mga problems, hindi na kailangan mag-first derivative test pa, hindi kailangan i-graph pa yung ating curve o yung function, o hindi na kailangan pang mag-substitute ng values of x na less than or greater than to the critical value para lang makita na talaga siya maximum or minimum. Ginawa ko lang yon para ipakita ko sa inyo na tama yung sagot natin. But dun sa mga susunod kong examples, hindi ko na gagawin yan. Okay? So we have example number 2, a closed cylindrical tank is to be made with a fixed volume. So ano ibig sabihin ng fixed volume? Ibig sabihin, volume is constant. Okay? So if you take the derivative of the volume, it is equal to 0. Okay? Kaya fixed. Pag sinabing word na fixed, other term yan na yung volume ay constant. Okay. Find the relative dimension of the tank which will require the least amounts of material in making it. Yung dimension tinatawag dito, yung height at saka radius of the circular base of our cylindrical tank. Na kung saan ang magagamit nating material ay least. Pag sinabing least, minimum. So ang ating gagawin dito, i-minimize natin yung material sa paggawa ng closed cylindrical tank. Okay? So, paano natin yun gagawin? Paano pang gumawa ng tank? So, dapat meron kang takip sa ibabaw at saka sa ilalim. Okay? So, yung ating material na gagamitin para sa ibabaw at saka sa bottom ng ating closed cylindrical tank at saka yung gilid, yung material. Okay? So, pag gagawa tayo ng cylindrical tank, may dalawa tayong circular base. Dalawa tayong circle. Okay? Ang diameter, ang radius natin is R. Ano pa? So, parang lata lang ng Alaska, carnation. Okay? So, para makapagawa nito, dapat may cover ka sa ibabaw, may cover ka rin sa ilalim. Pagkatapos yung lata mo, paikot. Okay? So, sa ibabaw, isang circle, circular material, tapos sa ilalim, isa pang circular material, tapos yung lata sa gilid para makapagbuo tayo ng closed cylindrical tank. Paano yung gilid? Yung gilid niya, pag tinanggal mo to, tanggalin ko ha. Okay, ito. So, ito yun. Pag tinanggal natin yan, yan. So, ito pa yung isang material natin kailangan. Ito yung gilid. Okay? So, ito yun. So, actually, siya ay rectangular. Okay? Pero pag inikot mo, siya na yung surface. Okay? Yung gilid. Pag tinanggal, rectangular siya. Now, yun pang kailangan natin na material. Paikot na yon. Kapag tinanggal natin siya, rectangular siya. Okay? Ano kaya ang kanyang height ng ating material na isa para sa gilid? Ang height niya is h. Okay? Yan siya. Pero ano kanyang length? Okay? Remember, bilog siya. Bilog. So, ito ay circumference. Okay? Circumference. Ang circumference natin, 2 pi r. 2 pi r siya. So, pag tinanggal mo yung pagkakabilog niya, magiging siyang length, yung ating circumference. So, therefore, yung circumference nung siya ay bilog, pag nilatag mo siya, magiging siyang length. So, ito ay 2 pi r. Okay. So, ito yung mga materials natin kailangan para makapaggawa tayo ng closed cylindrical tank. So, ito ang ating imi-minimize. Ano itong mga to? Ito yung mga surface areas na imi-minimize natin. Okay? So, gawa muna tayo ng mga variables natin. So, let A area of the circular base. Bottom na lang, bottom. Area of the bottom. Let's say ito yung bottom. Ito yung top. Okay? Area of the base. O circular base. And then, A sub T, sabihin natin itong area of the top. Anong area ng base? Ay di circle siya, pi r squared. Anong area ng top? Ganun din, pi r squared. Okay? And sabihin natin to, ito yung rectangle natin. Area of the side, gawin natin A sub S. Area of the side. Ang area niya ay the length times width. So that is, ito yung length, ito yung width, di 2 pi RH. Okay. So, gawin natin red. Pi RH. Okay. So, let's say, ang area of the side, let's say A, ito yung total area natin. A is total area. Ano yung total area natin? Ay the sum of these areas. So, that is area of the base, natin, plus area of the top, and area of the side. So, that is equal to 2 pi r squared plus 2 pi rh. Bakit naging 2 yun? Kasi dalawang pi r squared yun. So, that is 2 pi r squared. Okay? And then, meron pa tayong isang formula, no? Na makukuha dun sa volume. Although yung ating volume is constant, ang formula ng volume ng cylindrical tank is V equals pi r squared h. Okay? Ito yung para sa volume. Now, again, ano yung ating i-minimize o i-maximize? Least amount of material in making the closed cylindrical tank. So, ibig sabihin, i-minimize natin yung ating material. Sa case nito, i-minimize natin yung surface area. Okay? So, ito ang ating i-minimize. Minimize the surface area. Ito yon. Ito yung total area. Yan yung ating surface area. Total, lagyan ko para hindi nakakalito. Total surface area. Total surface area. Okay. So, meron na tayong illustration. Meron na tayong variable na i-minimize or i-maximize, and that is the total surface area. At the same time, we have here the formula for the volume, which is pi r squared h. And the last step is to determine the derivative of the resulting function. Okay. So, we have now a function. Ito yung surface area na i-minimize natin. We have 2 pi r squared plus 2 pi r. Papansin nyo na yung ating independent variables, dalawa pa. Okay? So, ibig sabihin, A is a function, or the area, surface area is a function of two variables, the radius and the height. Ang advice sa atin, sa second step, as much as possible, ilagay lang natin ito into one variable, one independent variable. So, paano natin gagawin yon? From the given volume, na kung saan volume is constant, we have pi r squared h. Pwede natin isolve dito si h, okay? In terms of the volume and the radius. So that is dividing both sides by pi r squared. We have h equal to volume over pi r squared. Okay. So para yung ating pong function will be as a function of one independent variable lamang, which is the radius. Okay, so substitute natin si h dun sa ating function. So we have a equal to 2 pi r squared plus 2 pi r, h is volume over pi r squared. So mapapansin nyo, may another tayong letter dito involved, which is v. Walang problema yon kasi v is not a variable. Constant siya. Okay? So, okay lang yon kasi if we get the derivative of v, that is equal to 0. Okay? So, we have a equals 2 pi r squared plus, cancel yung pi, cancel yung isang r. So, we have 2v r. Okay? To the negative 1. Tinaas ko na. So, we have a is a function of r na. Okay? So, kunin natin yung derivative. We have dA with respect to r. Factor out si 2 pi. Oh, constant naman siya. 2 times 2 is 4. So, we have 4 pi r. Plus, negative 1 times 2v. That is negative 2v r to the negative 2. Okay? And then, ibaba natin. Constant naman yung v. So, okay lang yon. Okay, naroon siya. So, we have dA over dr equals to 4 pi r minus 2v over r squared. Now, anong kasunod natin gagawin? Equate natin to 0 para makuha natin yung critical value. Okay? Now, this is 0. So, 0 na siya. 0 equals 4 pi r minus 2. Substitute natin yung v. V is pi r squared h. Pi r squared h over r squared. Yeah. And then, cancel yung r squared. Okay? So, matitira na lang is 0 equal to 4 pi r minus 2 pi h. 2 pi h. Transpose natin si 2 pi h. So, we have 2 pi h equal to 4 pi r. So, I'm going to divide both sides by 2 pi para masolve natin sa h. So, we have cancel. We have h equal to, cancel yung pi. This is equal, 4 divided by 2 is 2, so 2r. So, ito yung relative dimension niya para makuha natin yung minimum material sa paggawa ng ating closed cylindrical tank. So, this is our answer. The height should be twice of the radius. Okay? So, ganito yon yung tank natin. Let's say, kung ang radius mo ay ito r, ito dapat ay 2r. So, makatwid, kung ang radius mo ay 2, dapat ang iyong height 4. Okay? That is the relative dimension. So, I'm going to give you method 2 in solving example number 2. Thank you.